Assalamu alaikum. Hi folks, welcome back again to my channel. It's great to see you here again. Today's tutorial we're going to talk about three types or kind of t-test, which also called a student test. First of this test is one sample t-test, or also known as one sample parameter t-test. The second is unpaired or independent t-test with Welch and student test version. The third is paired or dependent t-test. We're loading these four packages: tidyverse for visualization, JPower to make Figure more attractive to ready to publish, Restatics to helps us to compute in the statistical test, and Datarium for loading us or allows us to load in these three kind of data frame. We first of all we might start checking with the normality of weight of the package or of the dataset mice. So in this case, my weight is a dependent variable, only one have only one group. So in this case, we want to check, for example, or apply one sample t-test. One sample t-test is used to compare, for example, in this case, the mean or average of weight, this dependent variable of dataset mice, and standard value, for example, 20, standard value or theoretical value. In this case, for example, we take 20 as a standard value. So first of all, we should take into consideration the assumptions of each test. The one sample t-test assume that the data, in this case our variable, follows a normal distribution. We can check it with this comment. First of all, we should put or write the appropriate data set, which is mace, percent, more than percent, and put or write Shapiro underscore test. And here we should write the appropriate variable, which is weight, and we click run. So in this case, the output indicate that the p-value is more than or greater than 0.05, which refers to that the weight variable follows a normal distribution. So we can assume that the data follows a normal distribution. In this case, we can, for example, or we might start to check in if there is a difference between the average of weight and, for example, standard value, which is 20. Using this following comment, mice percent or percent, and apply the function of t-test. Here we put the weight, which is the dependent variable, tilde 1, because we have only one group. For example, 20 is the standard value, which we should, for example, we want to compare it with average if there is a difference significant with average of weight, and we click to run. In this case, we have a p-value which is equal to 0.20 or 82. So this p-value is greater than 0.05, which refers to there is no statistically difference between the 20 value or the standard value and the average of the weight from the dataset mice. There is a twist. We can, for example, copy this comment and add alternative. If we want to, for example, select less. So if we, for example, write less in here, in this case, this comment allows us to, for example, check if the average of weight is less than 20. In this case, there is no statistically significant. And also we have another comment, which is greater. Also in this case is the inverse case. We invert the function of this command. So in this case, in this command, with the greater command, we, for example, want to check if there is, if the average value of weight is statistically significantly greater than 20. In this case, there is no significant value on the three or each three statistical tests. So in this case, we, for example, successfully apply the one sample t-test, and we test, for example, or compare the means of weight and 20, and also we test or check if there is or if the average weight is less than 20, or if the mean of weight is greater than 20. Now, moving now to the second type of student test, the unpaired or the independent student test. We use it to compare two groups that is independent, that independent from each other. In this case, for example, or in this test, we have two assumptions we should keep into consideration. The first is to check the normality also of each group. For example, we use the gender weight. In this case, the group which refers to independent variable have or has two kind of group, female and male, two gender. So in this case, we might want to check to might want checking the normality of each group, female and male, using this following or using this command. In this case, we should write gender weight percent more than percent group by for select the independent variable group, also percent more than percent, and Shapiro underscore test. In this case, for example, we put weight and click run. So the p-value of the two groups, female and male, indicate that the distribution of each group follow a normal distribution. The second assumption refers to the variance between the group. If the variance between groups is significantly difference, in this case, we should use the Welch t-test. If the variance between groups isn't significantly difference, in this case, we must use the student or the paired student t-test. So we have three, for example, type of or test to compare the variance. We have Fisher, Bartlett, and Levine. So, for example, take Fisher, for example, var.test. Data is gender weight and weight tilde group. In this case, the Fisher test to compare two variances indicate that the p-value is significant, which refers to that we have a difference significantly between two groups, female and male, in the variance. So in this case, we must apply the alternative test, which is Welch t-test. So, for example, I should copy this command here to put all the command in the comment below. So we should use the following all the command for testing the Welch t-test, using, for example, gender weight, which refers to the data set, percent more than percent, t-test, weight, tilde, and group, comma, var dot equal false or true. True. No, false. There is no homogeneity in the variance, so false. So in this case, the p-value is 4.30 multiplied by 10 raised to the power minus 19 or 18. In this case, there is a huge significantly difference between the weight value between the two groups, between female and male of the data frame gender weight. For example, if for example when we check we're using the var test, which refers to Fisher test. For example, if we have, in this case, if for example we have a non-significant p-value, in this case, we must apply the alternative, which is the t-test or the student paired t-test. In this case, we should, for example, only replace the false by true. This is in this case, for example, the alternative of Welch t-test. But we have significantly, as you know, a p-value significantly, which refers to a difference between, or significantly the difference between variance. So we should put here false. Moving now to the third test, which refers to the paired t-test. The paired t-test is used to compare the mean or the average between two mean, or two groups, or two dependent groups, two related groups. But there is important nuance, or there is a key point to notice, that the assumption of this test is different between, for example, the t-test on paired or on one single t-test. In this case, we must use this dataset mice2, which refers to two dependent variable before and after, the value of before, for example, treatment, and after the treatment. The assumptions of this test, of the paired t-test or of the dependent t-test, assume that the difference between before and after follows a normal distribution. So not in this case of the independent, which assume that each group follow a normal distribution, but in this case the difference. So we should, for example, or we must create a third column using the function mutate, for example, like this: mice2 equal to mice2 more than percent mutate. So we, for example, might want to create a third variable, which is differences equal to before minus after. So in this case, we use head function to show the first 6 rows of the newly one of mice2. So we have the differences between before and after. In this case, we apply. So I will take this, copy this command here, and also head mice. So mice2, like this, and we'll copy here. So in this case, the assumption assume that in this case of paired or dependent variable, assume that the differences between the related groups follow the normal distribution. So the same way we, for example, can check the normality, use mice2 percent more than percent, group or Shapiro, no, not group by Shapiro, through test differences. So in this case, the variable or the p-value of the output indicate that the difference or the differences follow a normal distribution. The differences between before and after follow a normal distribution. So in this case, we can apply the pair t-test using this comment, mice2 percent more than percent t-test. In this case, we should here, for example, put the dependent variable, which is, for example, the weight of each gender, and the dependent variable is the group or the gender. So in this case, our data set mice, for example, had mice 2 doesn't follow, for example, this statement. So we should, for example, transform this data set to another one following this comment. So we should write mice 2 equal to mice 2 percent more than percent gather to, for example, to create a independent variable which called k equal to, for example, gender. Sorry, gender. And for example, value, which refers to weight for before and after. After. We will also, for example, run again mice2. So in this case, we have, or we could, for example, write this comment view mice2. So the new data set represent the gender as data frame or gender as independent variable corresponds to before and after, and the weight refers to the value of each groups. So in this case, we can use the t-test pair t-test to check if there is a difference between the average between the two groups. So following this comment, we should put weight, for example, tilde, and independent. So weight is the dependent variable or the response variable, and independent or the explanatory variable is gender, and put period equal to true. So in this case, we have this output refers to the value of p-value, which is a huge significant or less than 0.05. So we can conclude that the gender, or there is a difference in the average of weight between the two gender, male and female.